Welcome back. We're going to be working on measures of center today for the Mod 8 guide. The first measure of center we're going to talk about is the mean, which you know as the average. The mean is also called the balancing point. I believe that you guys have been calculating averages for a long time. When you want to calculate your grade, typically you will add all the values together and divide by however many numbers there are. That's finding the average. We call it the balancing point because let's say I had two weights here, I would place the mean right underneath so that it would balance out the distances from the left and the right hand side. The question 2 says what's balanced? Well, the distances are balanced above and below. They zero each other out. So the distance away from this mean is, they zero each other out. I'm going to talk about that in just a second, but I want you guys to pick 4 numbers, any 4 numbers that you want, and find the average. So take a second, pause, come back when you're ready. Okay, I chose 1, 2, 3, 4. And you could have used duplicates, you could have used different numbers, you could have used higher numbers, doesn't matter. But I want to find the mean. The way that we find the mean is we sum each of the x values and we divide it by the total number in the sample. I'm going to add 1 plus 2 plus 3 plus 4. And there are 4 data points, so I'm going to divide by 4. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. And 10 divided by 4 is 2.5. So this is saying that the average is 2.5. Well, 2.5 isn't in this data set, but that's okay. It's what's going to balance out these values. I'm going to make a number line. And put a point for each of my values. So think of these as weights. Well, here's my median, or I'm sorry, here's my mean. And how far away each of these points are from the mean is zeroed out or balanced out. So the difference between 1 and 2.5 is negative 1.5. The difference in distance from 2 to 2.5 is negative 0.5. The difference in distance from 3 to 2.5 is positive 0.5. And the difference from 4 to 2.5 is 1.5. Now, if you notice, when you add these together, they total 0. And that's what the mean does. It effectively balances to where the values above and below, their distances from the mean will cancel each other out. Now we have a question of application where Jose wants to have an average of 80 for his exams. And he knows the score of his exams for the first 3, but he wants to know what's he going to have to get on the 4th one to get an 80 average. That means that we have 87 for exam 1, 72 for exam 2, and 85 for exam 3, but we don't know for exam 4 what he's going to get to average out to 80. So we're going to sum and divide by 4. Now, you could guess and check. You could plug in numbers and see what's closest to 80. You could calculate the average of the 3 exams and determine whether you need to go higher or lower for the value, or you could just solve equations. To solve this equation, you're using inverse operations. So I'm going to multiply by 4 on each side to cancel out the 4 in the denominator, that division. $80 times 4 is 320. And then I'm going to add these 3 values together. Adding those together, we get 200 and, look at my notes, 244. 244 plus that x is equal to 320. And again, we're solving for x, so we're going to undo this addition by subtracting. And we're going to get that x equals 76. That means that Jose needs to score 76 on this exam to get an average of 80. Question 5 is a learn by doing. It says, what's the mean of the dot plot pictured? Well, we're not just guessing here trying to figure out the balancing point. We want to know what it is because each of these values are shown. We know what the actual values are of each of these dots. So let's go ahead and write those out. We have 0 plus 1 plus 3 threes, plus 4, plus 5, plus 2 sixes, plus 9. Okay, we've taken care of all of those values. But remember, we have to divide by however many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 total. When you sum the numerator, you get 40. Divide it by 10, which means the average is 4. Okay? What about the median? We have another measure of center. So before we talked about the mean, well, now we have the median. And it says what's balanced on either side of the median? Well, the median is splits the data in two. There's the same number of data above and below the mean. And that is different when you have an odd number of data points and an even number of data points. Okay? If you have an odd number of data points, you're looking for the middle number. If you have an even number of data points, let's see. I'll go to the left here. If I have the numbers 1, 2, 3, 4, and 5, in the middle is the number 3. That's an odd number of data points because there's 5 here. If I have the numbers 1, 2, 3, and 4, well, in the middle here is actually 2.5. So what you're doing is you are averaging the middle two numbers. Okay, did I get this? Remember that you need to put an equal number of pieces of data on each side. So you want to split the data in half. Well, we have an odd number of data because there's 17, which means that we're going to have an actual value here. And then we're going to have a certain number on the left and a certain number on the right. And they have to be equal. What I do is I divide this number by 2, and I get 8.5. That means that we're going to have 8 on the left, 8 on the right, and 1 in the middle. 8 plus 8 is 16, plus 1 is 17. Going to the right on this graph, I have 1 in these little boxes here. Those are all a frequency of 1. Here's a frequency of 2, frequency of 3, frequency of 4, frequency of 5. That tells you how many scores are in that bin width. Now I want 8 on each side, so if I start adding from the left, 1 plus 1 is 2, plus 1 is 3, plus 2 is 5, plus 3 is 8. So I have 8 once I reach this bin width right here. So that means that the median is going to fall in this bin right here, where the 5 and the 4 are. Remember, the thing about a histogram is I don't have the exact values in the histogram. I just know how many are in that specific bin width. A note about this, sometimes you'll see these. The worksheets were not created by me, they were created by my colleague. And so she has specific places where she wants her students to stop. I am going to tell you guys this in class. I'll reiterate it again. I want you to work through the worksheet and then come back and check in with me once you're done. Question 8 says, what two things help us determine which measurement of center to use, the mean or the median? The shape and the presence of outliers. Those are our two deciding factors as to whether we're going to use the mean or the median. Okay? Let's pretend that we're dealing with home prices and Napa, and I have a dot plot of all of these values. Okay? And the average is 500,000. We have a whole bunch of values that average 500,000. Let's say that The Rock comes to Napa and buys a house, and it's a palace, and he spends 15 million. Okay, what's going to happen to our average? If we're adding all of these values together and dividing by however many there are, our mean is no longer going to be 500,000. It's going to be pulled towards The Rock's house. So the mean is going to be pulled towards the skewness. So it's not an accurate representation of the middle. That means that when we have a skewed distribution, the median is our go-to. And when we have a symmetric distribution, we can use the mean. A presence of outliers is, again, just causing attention or drawing attention to skewness. And another thing to note is if you are skewed to the right, like this picture above with the rock, the median is going to be in here, but the mean is going to be pulled to the right. So the median is less than the mean here. And if we're skewed to the left, the opposite is true. The median is greater than the mean. Okay, I'm going to pause here, and the next video we're going to concentrate on stack crunch.